Hi, I'm Tom.
I'm Ishaan, and we're going to be talking about random number generators. So randomness is really important on computers especially because they can aid in creating algorithms that are more efficient um, in recreation, things like video games and online casinos, in simulation, and many uses, many more uses. But most of these uses are only on computers. And so our question is, how do we generate randomness on computers? So there are many ways that we can get randomness. Like we can roll a die, we can measure radioactivity, and look at some of the digits, right? Uh, but a lot of these aren't compatible with the computer. So how can we generate randomness efficiently and quickly on computers? And it makes sense to generate numbers, obviously, since computers work well with numbers. But the problem is that computers are deterministic. And what that means is that every state, there's exactly one state that it's going to go to. It is completely predicted. And that is the exact opposite of randomness. So it's impossible for us to generate truly random numbers with only a computer. But the good thing is we can actually use really complicated algorithms to generate a sort of pseudo-random sequence of numbers. And these are what most random number generators use. Now, let's talk about distributions for a little bit. A distribution looks something like this. You have the different outcomes on the bottom and their respective probabilities. And the goal of creating a random number generator is to be able to model all possible distributions, so including this one, right? So obviously we could generate numbers, right, where one is a half probability, one is a third probability, one is a sixth probability. But we could also look at this and divide this up into blocks of equally likely outcomes, right? So for red, we would have three equally likely outcomes: green 2, blue 1, right? So that's numbers. So we could, for instance, have the numbers from 0 through 5. If they're all equally likely to occur, we could assign red to 0, 1, and 2, green to 3 and 4, and blue to 5. So this gives us the idea that we should make our generators generate numbers that are equally likely to occur. So this is what is called a uniform distribution. So one very common method of generating numbers is called the linear congruence method. It's very simple. We start with a number called a seed, and we're going to generate a sequence x1, x2, x3, and so on. And we're going to choose three other numbers: a, the multiplier; c, the increment; and m, the maximum. And with these numbers, we're going to follow this very simple recursion. To get the next number, we're going to take the current number, we're going to multiply it by the multiplier, add the increment, and take the remainder after dividing by m. And this can generate, and though simple, it can generate many different types of sequences, and some of which are very random-like.
So another way to generate random numbers is to use cellular automatons, and one that in particular that's really good at generating random numbers is Rule 30. So how Rule 30 works is at first you have an infinite row of white blocks, and then you have one black block in between. And then after that, you use a series of simple rules listed above, these 8 possible rules, to generate your diagram row by row until you get the entire diagram. From there, you can use a source of randomness, such as your system time, to take a specific section of the diagram, for example, a section of the middle column, and then you can interpret the white squares as zeros and black squares as ones in order to generate a binary number. So the last way to generate random numbers is through quantum computers. This is a very new, exciting way to do it. So what are quantum computers? Quantum computers, instead of using classical bits, use qubits, which are quantum bits that instead of being able to represent the states 0 and 1 separately, you can represent them together with varying probabilities. To visualize a qubit, you can use a block sphere, which is a 3D geometric representation of a qubit. And you can determine the state of your qubit by finding where your vector points to on the surface of the block sphere. So how exactly do we use quantum computers to generate random numbers? Well, quantum computers uses logic gates just like classical computers, except these are quantum logic gates. And one in particular, the Hadamard gate, it will transform a qubit in the position of 0 to a wave function of 1 over root 2, 0, and 1. And what that means is that when observed, you will get a 1/2 probability of observing a 0 and 1/2 probability of observing a 1. That's because the Born rule states the probability of observing an eigenstate is the square of its coefficient. So what this means is that with n qubits, you can generate an n-digit binary number. And since, because of our current understanding of quantum physics, each qubit, the probabilities are exactly half, the total sequence will be random as well.
So in conclusion, we've talked about a couple of ways to generate numbers. One of the most promising being quantum computing, but there are other ways. So for instance, there's a linear feedback shift register, which is like an expanded version of the LCG. They're Fibonacci-esque recursions that are also very similar, variations. There's some with x squared terms.
And there are many statistical tests you can use to determine whether generators are truly random. For example, you have the Monte Carlo method, you have the chi-square test, you have the KS test, and these are all tests you'll be able to see in the full version of our presentation.
All right, so that's all we have. Tong made a demo that you can play around with some of these RNGs at either of those two links. And that's all.